Hello again, everyone. Here we go. Practice test number 2. Let's look at. There's 10 problems in it. Let's look at them. I've written a few of them down already, kind of make it a little easier for us to go through them a little more quickly. For this one, they say simplify. As is. Okay, well, u is the same as 1u. Negative 2 distributes this way. You got negative 2u. Negative 2 times 2 is negative 4, and 1u is 1u. Negative 2u and positive 1u, common terms here, guys. So you keep the common term, as we said. Negative 2 and 1 is negative 1. There's your u. The negative 4, there's not much to do with it, other than just leave it there. You can write it like that. You can write it as negative u plus negative 4, or negative u minus 4. There's a number of ways this can get looked at. But that's essentially the argument. Here they're saying solve for u. Whenever you're solving an equation, you have to do the exact same. Whenever you solve an equation, you have to do the exact same thing on each side. It's kind of an interesting point here. Whenever you're solving an equation, you're undoing the equation. Perfect example. When you're talking about order of operations, what gets done first? Brackets and parentheses. After that, exponents and roots. After that, addition and subtraction. There's other things as well, but let me try to, basically it's that. It's brackets and parentheses are the first priority when you're actually just evaluating something that's been given to you. You deal with brackets and parentheses. Everything within brackets and parentheses has the highest priority. After that, you're doing exponents and roots. After that, you're doing multiplication and division. I forgot to say that earlier. Multiplication and division. So brackets and parentheses, powers and roots, multiplication and division, at the very end, addition and subtraction. When you're solving an equation, you reverse that whole process. You get rid of stuff that has addition and subtraction in it. Then you get rid of stuff that has multiplication and division in it, and so on and so forth. So a little bit, you're kind of undoing the problem in a sense. What are we trying to say here? Well, I'll tell you what, I'm going to undo the fact that there's an addition there going on. I'm going to add a negative 8 on each side, or subtract 8. It means the same thing. Adding a negative 8 or subtracting a positive 8. If I add a loss of 8 or just take 8 away, it's the same answer. I'm going to add a negative 8 on each side. 8 and negative 8 is nothing. Negative 2 and negative 8 is negative 10. It's a little easier to look at if you do it that way. Negative 10 equals 5u. Another way to write that is 5u equals negative 10. You do the same thing on each side. If there's a positive number in front, you divide by a positive number. If there's a negative number in front, you divide by a negative number. I'm going to divide by 5 on each side. You've got to do the same thing on each side. Negative 10 divided by 5 is negative 2. And there you go. 3. For problem number 3, each of the past 5 days, Teresa traveled 58.9 miles. For each of those 5 days, she traveled 58.9 miles. How many miles did she travel in all? Well, it's 5 days. Each one of them, 58.9. Again, you got calculators for this. A lot of ways we can go here. Multiply that out and see what happens. I mean, you could kind of say, on this one, you could say 295 minus 0.5 is 294.5, if you were to do this in your head. 294.5. Let's see what happens here, actually. We got this. In fact, I shouldn't have said what I said. I mean, I guess I am wrong on that one. What would this have been? This, no, I'm gonna go with that. I'm gonna stay. Very odd. Let me give me 1 second here, folks. I would say it's 1.13. Yeah, I would. I'm gonna stay where I was at. Yeah, I'm gonna stay where I was at, guys. I'm gonna say 294.5. So do this right here. You got that. This is 29. 1 decimal place. There it is. You can do it with a calculator, you can do it in your head. Just get it right. Even if you get it right, nothing wrong with questioning yourself. I had it right, and I still wasn't quite believing what I was getting for an answer. But there it is. If she went 58.9 miles every day for 5 days, 58.5 miles each day of 5 days, you're going 5 times 58.9, and you're getting that for an answer. Solve for V. I would add a positive 3/4 on each side. Do the same thing on each side. Negative 3/4 and positive 3/4 is 0. You got the V right here. V is going to be 7/8 plus 3/4. Simple as that. 8 is the common denominator. Special one is 2/2. Let's see where this is going to go. 2 times 3 is 6. 2 times 8, 2 times 4 is 8. Add these together. You got, you're leaving the common denominator. You got this, which is the same as, there's a number of ways you could write this. You wrote this as a decimal. I don't think anybody's going there, but if they did, 1.625. They all mean the same thing, guys. V is 1.625, is 1 5/8, is 13/8. They're probably stopping right here. We can look at it. For the heck of it, we can go right there. Let's see what that was. That was number 4, right? Yeah, the 13/8 is where they stop. But again, it's good to have the versatility, guys. Different ways you want to look at this and get to where you want to go. So they're saying solving for W right here. Tell you what, here it is, huh? Minus 36 is plus a negative 36. This negative 8 will go over here, and let's see if this simplifies, or at least gives us some kind of a look that we feel pretty good about. Negative 8 times W is negative 8W. Negative 8 times 6 is negative 48. Let's get the W's over to one side. Let's get the numbers over to the other side. What do you say we add a positive 8W on each side? You add these together, you get 2W. You add these together, it's gone. Got 48. Add a positive 36 on each side. That's out of there. You engineer it to be out of there. This and this is negative 12. 2W equals negative 12. Divide by 2 on each side. Always divide by the exact same number that's in front of the letter. If there's a positive in front of the letter, divide by a positive. If there's a negative in front of the letter, divide by a negative. Divide by the exact same number that's in front of the letter. Whatever the sign of the number is, put the exact same number as division on each side. If you're going to multiply by a reciprocal, if there's a positive in front, you multiply by a positive reciprocal. If there is a negative in front, you multiply by a negative reciprocal. You're always dealing with the same signs when you're solving a multiplication or division going on. Divide by 2 on each side, you got this. You should be there. They want you to solve for x. And we can certainly do that. We may need a little more room, so I may have to get rid of this 5 right here, and we'll take care of the 6 as it is. So let us see. Okay, let's see where we are. we already here, we got to get x for an answer. We got to get x. I'm going to figure out what x actually is. It's tough to get a definitive answer in terms of a specific numeric value. Okay? Essentially, you guys, make this a little more obvious right here, guys. In terms of getting a specific numeric answer, you can't really do it. There's too many letters there. You always need as many equations as you have unknowns if you're going to have a chance of getting some sort of numeric answer, or any kind of answer for that matter. The symbolism can be used in various ways, even with symbols. If you want to get specific answers, you want really a real good chance of doing so, you need as many equations as you have unknowns. You need as many independent equations as you have unknowns. I have only one independent equation here, and there are 3 unknowns. So I just have to solve in terms of what I have right there and leave it at that. I got to get x all by itself, you guys. So the way you're going to look at it is, let's go for it. You got it right here. Let me see what I can say. There's probably a number of ways to go here. I'll tell you what I'm going to do. Since this is an entire quantity, don't touch it until you get rid of this guy. Or you could distribute this and do it as well. Tell you what I'm going to do. I'm going to divide by k on each side, and that's going to be out of there. And what you end up getting is, you got 4 plus x, that quantity, equals z over k. That's the same as just this. If you subtract 4 on each side, or add a negative 4 on each side, you got z over k minus 4. There's a number of ways that can be written. Certainly a number of ways that can be written. But for problem number 6, this is what we're looking at. Let's just have a look. Just to make sure. I mean, it's a little, there's some ambiguities that can happen here. Yeah, x equals z over k minus 4. That'll work. That was 6. That gets us through 1 through 6, everyone. Let's go 7 through 10 and see what we can say here, guys, regarding some of this stuff. A construction crew has just built a new road. It took them 8 weeks to build 20.48 kilometers of road. At what rate did they build the road? Okay, classic division problem. A construction crew has just built a new road. It took them 8 weeks to build 28.48 kilometers of road. At what rate did they build the road? Depends what they're asking. You know, they could get funny with us and tell us, well, what rate is that per day, not per week? What is it per hour? You know, heck, what is it per year, or what is it per decade? You always divide by the time frame that you're asked to divide by. If they're saying it took 8 weeks, it's kind of implied you're going to be using weeks. You're always dividing by the time frame, by the amount of time that they gave you, using the units that they gave you. It's probably the easiest way to look at it. If they're doing 20.48 kilometers, and they're doing this in 8 weeks, that's your division. You know, luckily we got a calculator, we can go with that, we can go, you know, we do a lot of stuff, you know. So you can look at it. If I'm looking at this, to me, I mean, just if I tried to do this in my head, man, I don't know if that's actually a good idea or not, but I'd say 2.56 is what I'm thinking. 2.56 kilometers per week. That's my guess. Now I'm gonna confirm that. I'm going to look and try to confirm that with a calculator and see what we can say here. 20.48 divided by 8. 2.56. Yeah, comes out okay. Always check it. You've got the calculator, folks. Look at what's going on. Let's take it from there when we do it. For number 8, write inequalities to represent the situation below. And here we go. At the airport, each piece of luggage to be checked must weigh in at most 45 pounds. That's the most it can be. Use W to represent the weight in pounds of a piece of luggage that can be checked in. To get the 10% discount, a shopper must spend no less than $400. That's a different problem. Use D to describe that. So we got 2 different scenarios here, guys, to want to look at. As we look at it, so the luggage has got to weigh less than 45 pounds or at most 45 pounds. So that's this. The other one, to get the 10% discount, a shopper must spend no less than $400. Use D to represent the spending in dollars of a shopper who gets the discount. D is the amount you shop. You got to spend $400 or more. So here are 2 different scenarios to see where they're at. And let's just make sure we're reading this correctly. We should be fine. W, correct. W is less than or equal to 45, and D is greater than or equal to 400. Sounds good to me. All right, let's look at 9 and 10. So for 9 and 10, you guys, they say use substitution to solve the equation. Well, there's a lot of ways we can do this question. I guess we can go a little extra on it and kind of kill a couple birds with one stone, so to speak. What you can do is they're saying, okay, well, okay, now I guess there's not really extra. I think we got to have to do what I was thinking of doing anyway. So let's look at 9, you guys, and see what we can say. Basically, solve for one of the variables in one of the equations and then plug it into the other equation. This is all easier done than said, folks. So let's take a look at it. There's a number of ways you can play this. Negative 4x plus 3y equals negative 24, and x minus 2y equals 11. Well, let's take this. Let's try to do something simple with it. Let's take this. Let's add a positive 2y on each side and see what happens. Here's an x. Minus 2y or plus a negative 2y, and 2y is 0. Minus 2y plus 2y gets you back to 0. This is 2y plus 11. This is what you're going to use to substitute. Wherever you see an x in the other equation, you will plug this in. You'll take it from there and you'll be fine. You're going to put an x, in place of x, up here, in place of the x right here, you're going to put this quantity. You're going to solve for y and then come back. It's kind of easier done than said. Let's just do it. This is called the substitution method. We'll see the elimination method right after this. So we see this right here. Okay. Negative 4 times x. We just said x is going to be equal to this. Wherever you see the x, you're using this, 2y plus 11. So in place of x, you're going to put 2y plus 11. Plus 3y equals negative 24. Now what did you accomplish there? You got one letter to deal with, guys. If you go here, negative 4 times 2y and negative 4 times 11. Negative 4 times 2y is negative 8y. Negative 4 times 11 is negative 44. 3y is 3y. Negative 24 is negative 24. negative 8y and 3y, negative 8y and 3y, negative 8y and positive 3y is negative 5y. So far, so good. Let's add a positive 44 on each side, get rid of the negative 44. Let's add a positive 44 on each side. Negative 44 and positive 4, it's out of there. You got negative 5y, negative 24 and positive, negative 24 and positive 44 is 20. Negative 24 and positive 44 is 20. Again, it's good to add, you guys. It just makes things easier. It really does tend to make things easier. Divide by a negative 5 on each side. You're always dividing by the number in front of the letter, the coefficient, they call it. 20 divided by negative 5 is negative 4. Y equals negative 4. Once you got y equals negative, you got to solve. You need as many equations as you have unknowns. We have two unknowns up there, an x and a y. I need two independent equations to be able to solve it. If I had 20 unknown quantities, I would need 20 equations to do the job. Well, in this case, I got two unknowns. I need two equations. And here we go. We did it. Now, why don't you plug in, why don't you find out what x is? Plug in the value you just found for y. Y is negative 4. Sounds good to me. I mean, 2 times negative 4 is negative 8. 2 times negative 4 is negative 8. Negative 8 plus 11 is going to be what x is equal to. X is going to be equal to 3. X equals 3, and y equals negative 4. Absolutely. Absolutely. X equals 3, y equals negative 4. And if you plug in those values, x equals 3 and y equals negative 4, x equals 3, y equals negative 4, x equals 3, 3 times negative 4 is negative 12, y equals, y equals negative 4. So x equals 3 times negative 4 is negative 12, y equals negative 4 times 3, that's also negative 12. Negative 12 and negative 12 is negative 24. If you put x equals 3 right here, minus this quantity, well, 2 times negative 4 is negative 8. 3 minus a negative 8, minus a negative 8 is plus 8. 3 and 8 is 11. Hey, it works out. If you plug in the correct answer, if you plug in the correct ordered pair into each one of the original equations, they both work out. It confirms that you solved it correctly. Very important. So that's pretty interesting. That is number 9. Number 10, we could probably do this with the elimination method, number 10. You'll see when I get there. We did the substitution method right here, but let's see. See what we got. All right, for number 10, you'll see, sometimes circumstances. We did the substitution method for problem number 9. Problem number 9, we did the substitution method, but for number 10, we don't need to go there. There's a simple addition that can take place that maybe makes this pretty easy to look at. They're giving us this problem. This is called the elimination method. Problem 9 was the substitution method. This is going to be the elimination method. Use either method. Use either method, just get it right. At the end of the day, make sure you should know how to do both, and probably most important of all is make sure you get it right. Well, this is the problem. Well, I'll tell you what, guys. I mean, this is maybe an easier thing to look at than you might think. Let's get one of the letters by themselves, and man, we're right at it. We're looking at it. There's a 2y here. There's a negative 2y here. Minus 2y is plus a negative 2y. What is 2y and negative 2y added together? Just add both equations. 3x plus 6y, 3x plus 6x. 3x plus 6x is 3x. 2y and negative 2y is 0. 8 and negative 20 is negative 12. Pretty easy to look at this point. Divide by 3 on each side. Divide by 3 on each side. Negative 12 divided by 3 is negative 4. I'm halfway there. You can go to either one of the original two equations, plug in x equals negative 4, and solve for y. The first one maybe looks a little easier. It's not quite as complicated. But either one of them works. You're not obligated to do one or the other. Negative 3x plus 2y equals 8. X equals negative 4. Negative 3 times negative 4 is positive 12. Let's subtract 12 on each side, or add a negative 12 on each side. Adding a negative 12 is the same as subtracting 12. That's out of there. 2y is 2y. 8 minus 12 is negative 4, or 8 plus a negative 12 is negative 4. That doesn't matter too much. And you got to here. Divide by 2 on each side. Negative 4 divided by 2. Negative 4 divided by 2 is negative 2. X equals negative 4. X equals negative 4, y equals negative 2. Let's have a look. Yeah, x equals negative 4, y equals negative 2. It's as simple as that. You could have done the substitution method on this also. Similar procedures to what we did right before this. But this is a lot of what's going on, you guys. Let's just make sure something careless didn't happen here. 3 and negative 4 for number 9, and negative 4 and negative 2 for 10. Okay, looking good. All right, guys, that's test number 2. We will talk again shortly.